Hey everyone, and welcome to this new lecture on sequence and series. Today we're going to begin with this new topic of sequence and series. We just got done with our previous topic, and that was on probability, in which we discussed the basics of probability and the permutations and combinations, and how to figure out which question requires permutations and combinations. For this lecture, we would now be starting a new topic, and that is sequence and series. And the first subtopic in that sequence series module is going to be arithmetic progression. We basically have two types of progressions that we're going to discuss in our syllabus for this topic. One is the arithmetic progression and the other is the geometric progression. Thus far for this lecture we're only going to concentrate on the arithmetic progression. We're going to talk about the different formulas. First of all, we're going to start with the definition of arithmetic progression. Then we're going to talk about the different formulas that are required for arithmetic progression for the calculations, and that can help us in large arithmetic progressions. You would see that just like probability and many of the stuff that we've been using in the real life, arithmetic progression is also used by us in real life. So before I explain how that is so, let's just start with the definition of arithmetic progression. So before that, we'd have to discuss what is a sequence. So like the definitions tells you on the slide, that the list of numbers having specific relation between consecutive terms is generally called a sequence. Basically what it means is what is shown to you over here on the slide, that is 1, 3, 5, 7. Now you see that both the consecutive numbers 1 and 3 have a specific relation between each other, and the relation is that the second term is 2 more than the first term, and the previous term is 2 less than the next term. So that's 1 plus 2 is equal to 3, 3 plus 2 is equal to 5, 5 plus 2 is equal to 7. This is how this sequence is formed, because since they have a particular relation with each other, we can call this a number 1, 3, 5, 7, this list of numbers, or these four numbers over here, a sequence. And just like that, since we know that every next number is found by adding 2 to the previous number, we know that if it were to continue, if the sequence was to continue, we would have 7 plus 2, 9 as the next number, and 11 after that. Just like that, if you look at the next sequence, we have 2, 6, 18, 54. Over here the relation is different from the previous one. Over here the relation is that of a multiplication. At first you would say, okay, like we just add 4 to the first term, we get 6. But if you look at the third term, it should have been 10 by that rationale, that if you're just adding 4 to the previous term. But that's not the case over here. So we see that the relation between the two terms, the consecutive terms in this sequence, is that the first term is being multiplied by 3 to get the second term. So 2 multiplied by 3 is equal to 6, 6 multiplied by 3 is equal to 18, then 18 multiplied by 3 is equal to 54, and if we were to continue this, we would get 54 multiplied by 3, that is going to be 162. So this is what a sequence is. If you have a list of numbers, if you have some numbers which have a relation with each other, you can say that they have a sequence. Now, moving on, what is arithmetic progression? If various terms of a sequence are found by adding a fixed number to the previous term, or difference between the two successive terms is a fixed number, then the sequence is called an arithmetic progression. For example, over here we see adding 2 over here is going to form a arithmetic progression. 2 plus 2 is equal to 4, 4 plus 2 is equal to 6, 6 plus 2 is equal to 8. Just like that, in the second sequence that we see over here in gray, that is 5 plus 2 is equal to 10, 5 plus 5 is equal to 10, 10 plus 15 is equal, 10 plus 5 is equal to 15, 15 plus 5 is equal to 20. We see that any two terms are found by adding something to the previous term, or subtracting something from this term to get the previous term. If you have that in a sequence, you will call it an you will call that sequence an arithmetic progression. Just like in the previous slide we saw, the first example that we saw, 1, 3, 5, 7. This will be called an arithmetic progression because the difference between the two consecutive numbers, the relation between the two consecutive numbers, is that of addition and subtraction. 1 plus 2 is equal to 3, 3 plus 2 is equal to 5, 5 minus 2 is equal to 3. So that is how we know that this particular sequence is an arithmetic progression. Now if you want to see what arithmetic progression is in an illustration, you can see that you have, starting with A we can say is the starting point, just like in the English alphabet, A is the starting point. So we have A over here, then you have these pink faces, that pink smileys that are going to represent a D. So you're adding a D over here. So basically what you're getting is and a plus d over here in the second one. Then you add another d over here, but you get the third term, which is a plus 2d. Now if you look at the third term, if you were to minus 1 smiley face from this, we are going to get as the second d, that is a plus 2d minus d. We remove this one, we would get a plus d, that is the second term. Just like that over here, if you want to know the third term over here, so we know that the first term is a is equals to 2 over here. The difference between these two is 2. So if you want to know the first term, we're going to get a plus d, and that is going to be 4. If you want to do the third term, we have a plus 2d, that is going to be 6. So just like that, we have the examples of arithmetic progression. We just need to find out the relation. If it is an addition and a subtraction, you know that it is going to be an arithmetic progression. So the general formula of arithmetic progression, just like I told you in the previous examples of the smiley face, and I related with the slide before that, this is the general formula of arithmetic progression. We have certain terms. We will use a as the first term. This is a convention that we're going to be using in this topic. A is the first term, and d is going to be difference. D is for difference, the word. So d is going to be the difference, and a is going to be the first term. By first term, of course, we're using a as that because in the English language, a is the first term. And then we have a particular formula, that is, if you want to find out the fifth term, how are you going to find that? N over here represents the term. N over here represents the term. So for example, if you were to find the second term, if you want to find out the second term in this example, let's just say we take this example over here, 5, 10, 15, 20, 25. So if you look at the slide over here, we know that the first one was a was 5. We know that the difference is 5 as well. So if we want to find out the second term in this arithmetic progression, we just put 2 over here. So what's going to happen is a plus 2 minus 1, that's going to be 1, that's going to be a plus d. With that, we're going to get the second term. We know a is 5, we know the difference is 5, so we're going to get the second term, that is 10. That is exactly how it is in this small sequence that we see over here. Let's just say we want to find out the fourth term. The answer has to be 20 if this formula is right. In order to find that out, we plug in the values. The a is going to be 5, of course. D is going to be 5 as well because the difference is 5. N minus 1. Now n over here is 4 because fourth is the term. Fourth, we want to find out the fourth term of the sequence. So what are we going to do? 4 minus 1, that's going to give us 3. So the equation is going to become 5 plus 3 into 5. That is 5 plus 15. That is going to be the fourth term is going to be, that means 20. So just like that, we see over here that the fourth term is 20. So this is a general formula if you want to find out a particular term of an arithmetic progression sequence, a sequence that grows according to the arithmetic progression. So this is the formula to do that. Now this is the common difference, the fixed number which is obtained by subtracting any term of the arithmetic progression from its previous term. Basically, it's just another way of looking at it. We said that after the third term you can add 5 and you're going to get the fourth term, that is going to be 40. And that is going to be 20, sorry. Another way of looking at it is that if you have the fourth term, that is 20, and if you want to find out the third term, you subtract the difference between them and you get the third term. That is known as the common difference, and the third term is going to be 15. So this is how it is. And this formula that we discussed already, a, you can remember the capital A is the arithmetic progression, n is the number, is the term, specific term that you want to find out. A or small a is going to be the beginning, the start of the sequence, the number at the start of the sequence, and n minus 1 into d. So n minus 1 is going to be, of course, we have n over here, the specific term that we want to find out. We're going to subtract 1 from it, and then we're going to multiply it with the difference, and we're going to get the particular sequence. Now we look at this sequence over here, 3, 7, 11, 15, and 19. Now we know that it's really simple. This one is once again really simple. We just have to add 4 over here, and we're going to get 7, then 4, 11, and then 4, 15, then 4, 19. We go reverse, we minus 4 from each of the terms, we get the previous term. So difference over here is 4. The starting term is 3. A is equals to 3 and the D is equals to 4. Now that we know that, we can apply the formula to it. Let's just say we want to find out the fifth term. So it's very simple. I mean, this example is just to get those started who have no experience in sequences or arithmetic progression before. You see, you just plug in the values. A is equals to 3 and n, of course, we know is 5. Because we want to find out the fifth term, we subtract it from 1 and then we multiply it with the common difference, that is 4. and we get 3 into 4 multiplied by 4, and that is 16, and we get the fifth term, that is 19. 1 2 3 4 and 5. The fifth term is going to be 19. Now moving on, so this is this is another one of the explanations of how to solve that. If you want to find out the 12th term in the exam, you're not going to see it like this. You're never going to see it like, you're never going to have an exam in which it says A is equals to this, D is equals to this, and N is equals to this. You're going to have, most probably you're going to have a sequence. They're going to tell you that a sequence of terms that grows arithmetically has a first term 2, and the difference between two terms is 2, and find out what is the 12th term in the sequence. So you don't have to worry about anything. Just remember this formula: a plus n minus 1 into d. This is how an arithmetic progression sequence grows. All you have to do is plug in the values: 2 over here, d over 12 over here, and d over here, and then you have the answer to your question. Now let's just say we want to find out whether a given term is in arithmetic progression or not. So the first term over here is 2. Now if you just look at it, of course it's really simple one. We're using really simple examples over here. The first one is 2, then you add 4, then you add 4, then you add 4. So you have all of these this series with the particular difference of 4. But if you want to find out whether a particular series is a arithmetic progression or not, the best way to do that is, rather than finding out what you're adding in between the two terms, the best way to do that is that you subtract one term from the previous term, and then you see the answers of it. For example, you subtract the second term from the first term. Then for starters, if this is a question in your exam, or like a little bit complex, a little bit much more difficult than this one. So you have 6 minus 2, you're gonna get 4. Okay, so you know that the difference between the first two terms is 4. Just check the third and the second term. The third and the second term show you that 10 minus 6. 10 minus 6 is 1 again 4. Once again 4. And then 14 minus 10. 14 minus 10 once again gives you 4. So you see the difference between the terms is 4. That is, they have a common difference. So now we know, since the differences are common, we know that the given terms are in arithmetic progression. This is the way to find it. If you want to find whether a particular sequence is growing arithmetically or not, it's in arithmetic progression or not, the way to do that is that you try to find out the difference between the second and the first term, the third and the second term, fourth and the third term. And once you do that, you would know whether this is in arithmetic progression or not. So now let's take this problem over here. Find the value of k for which the given series is in arithmetic progression 4 comma k minus 1 12. So this is the series that we have: 4 comma k minus 1 comma 12. Now they already told us that in the question that the given series is in arithmetic progression. What did we say? That how do we find out if something is in arithmetic progression? We subtract the second term from the first one, third one from the second one. That's exactly what we're going to do over here. We take the second term and subtract it from the first term. Second term is k minus 1. We subtract it from 4 over here. We take the third term 12 and subtract it from the second term k minus 1 over here. So we have this really nice equation, really simple one over here. K minus 1 minus 4 is equals to 12 minus k whole k minus 1. You multiply this whole by negative, you get minus k minus 1. You have minus 1 and minus 4, you get minus 5 over here. So you get k plus k is equals to, bring both the k's on this side and you bring the 5 on that side. K plus k is equals to 18. So 2k is equals to 18 and k is equals to 9. What that proves is that k is 9, so the second term is going to be 8. So if it's really common sense after that, that basically is growing arithmetically, because 4 plus 4 is equals to 8 and 8 plus 4 is equals to 12. So this is the way that, the main thing that you have to do is that you have to concentrate on the question. The question says, find the value of k for which the given series is in arithmetic progression. Now we know that what do we have to do for a term that is in arithmetic progression. We know the properties of that. In order to find out something in if it is said that it is in arithmetic progression, it is thus proven that the difference between the second and the first term and the third and the second term and the fourth and the third term is going to be same. So you use that fact, you use to find out the unknown variable, that is k in this case, and then you get the answer. Another thing that you could have done in this case is that you could have used the formula that we discussed over there. The formula that was a plus d minus 1 into 2. Now you see, you could have used that. You could have said k plus n minus 1 into 2. You could have used that formula, and then you could have plugged in the values. You know that the particular term over here is going to be k minus 1. So k minus 1 is going to come on the left side of the equation, and then it's going to have 4 is equals to 2 minus 1, because we know the second term is k minus 1. 2 minus 1. Now here's the problem. We don't know what the difference is. So you see, if you would have used the formula, you would have had a problem. If had you used the formula, this formula over here, in this case there would have been a problem, because we don't know what the difference between the equations is. We don't know what the difference between the equations is. So we would have written k minus 1 over here, 4 over here, 2 minus 1 over here, and then here we would have been stuck. We would have had two unknowables in a single equation, and that's not solvable, of course. So the way we did that is that we basically, the thing that we did not know, we basically eliminated that. We basically equated the thing that we did not know, that is d of both the terms, that is second in the first term and third in the second term. So through that we found out this particular answer to k minus 1. So this is pretty much it for the first lecture in this series. There's a lot more that we have to cover, of course, and we are going to do that in the next lectures. This is just the beginning. It was some really basic introduction to arithmetic progression, just the basic formulas, a little slightly complex question, but not that much. So hopefully we'll start with the much more advanced stuff in the next lecture, and hopefully I expect you guys to be there. Thank you very much.